It hit with the force of 10,000 nuclear weapons.
General, we've got 11,000 people at NASA trying to figure that out right now. When we know, you'll know.
Every year, dozens of asteroids that are big enough to cause regional devastation pass within 5 million miles of Earth, with one or two of these space rocks being huge enough to be cataclysmically destructive to the planet pass by each year. At some point in the future, Earth will almost certainly face a space rock large enough to obliterate huge cities, or even cause an event that can eliminate all life on the planet. To prevent these destructive impact events, NASA has outlined specific plans to hunt these possible threats and have stepped up efforts to prepare for imminent asteroid deflection. In this video, we're taking a look at NASA's plan to save Earth from asteroids. Before we jump into it, hit that thumbs up button to show your support, subscribe, and ring the notification bell for future uploads. This is TechBinge. Currently, there are 723,367 individually identified asteroids in our solar system, and every day Earth is bombarded by tons of dust and sand-sized particles coming in from space. Meteoroids burn up as they enter the Earth's atmosphere, causing little or no damage at all. Of more concern are the asteroids that pass by Earth unnoticed, as they can be difficult to detect and track owing to the fact that observers depend on the reflected sunlight to even spot them. Every 6 years, one of these tracked asteroids pass by 185,000 miles from the planet, roughly 53,000 miles closer than our moon. This particular asteroid is called Bennu, a coal-black asteroid that slowly rotates as it orbits our sun. It's 1,650 feet across, and is likely a crumbly pile of carbon-rich rock held together by gravity, with a 1 in 2,700 chance that it could sail close enough for our gravity to reel it in, which is going to happen in about 200 years. The possibility of Bennu impacting Earth would create a crater nearly 3 miles wide and 1,500 feet deep. That impact would trigger 6.7 magnitude earthquakes and may cause the surrounding air to burst, collapsing buildings and tearing down trees up to 30 miles away. The ability to assess the potential damage when an asteroid like Bennu striking Earth is important, and so are the appropriate steps to reduce the severity of these natural disasters, allowing faster and more accurate simulations and risk models from state-of-the-art supercomputers. This is what researchers working on the Asteroid Threat Assessment Project in the NASA Advanced Supercomputing Division at Ames Research Center are doing by utilizing a unique combination high-fidelity computer simulations and probable risks posed by asteroids to provide more detailed estimates of the possible damage that a strike on the ground may provide. Knowing ahead of time what sizes and types of asteroids that pose a significant threat and what damage they may cause is critical to planning the strategies to reduce risk. In 2018, NASA released the National Near-Earth Object Preparedness Strategy and Action Plan, an 18-page document that outlines the steps that NASA and the FEMA are implementing within the next 10 years to prevent dangerous asteroids from striking Earth and prepare the country for the potential consequences of possible impact. There are 5 major objectives detailed in this plan, with the first directing NASA to lead a new effort to enhance the capabilities for detecting, tracking, and characterizing near-Earth asteroids for more accurate modeling and more effective decision-making. There are already numerous ground-based observations that could constantly scan the skies for asteroids, such as the Catalina Sky Survey in Arizona and the Pan-STARRS-1 telescope in Maui. The plan intends to enhance existing programs and develop new ones to further improve detection and tracking capabilities. The second goal is to improve modeling, prediction, and information integration across U.S. agencies to help predict the probability that an asteroid will hit Earth and determine exactly when and where it might strike. Emergency management teams like FEMA can use this information to determine the best course of action for preparedness and actual implementation after the impact happens. The third identified objective for NASA is to come up with new ways of deflecting an asteroid heading towards Earth by developing new technologies for rapid response missions, in which a spacecraft could possibly alter an asteroid's course so that it no longer poses a threat. Plans for asteroid impact avoidance for near-Earth objects have always been a NASA objective to thwart major impact events. Once a threat of possible collision is identified with plenty of time prior due to accurate models and analysis, deflection efforts may be pursued. One of these prospective plans of action is the Double Asteroid Redirection Test, or DART, which plans to slam a spacecraft into an asteroid when it's still far from Earth in order to alter its course. Any change in the asteroid trajectory may provide measurable insight of whether it has been successfully deflected. Another possibility of achieving deflection is by initiating a nuclear explosive device above, on, or beneath the surface of an asteroid to nudge the celestial body off course by the tremendous explosive energy, but also pose higher potential risks. An alternative to explosive deflection is to move the asteroid slowly over time. The Asteroid Redirect Mission Vehicle is a concept that pushes a gravity tractor as a planetary defense technique on a more hazardous-sized asteroid by using an unmanned spacecraft hovering over the asteroid to gravitationally pull it to a non-threatening orbit. However, this technique would likely have to spend several years beside the asteroid in order to be effective. Another possible means of deflection is a familiar concept similar to movies we've seen in recent years. The Hypervelocity Asteroid Intercept Vehicle combines a kinetic impactor to create an initial crater within an asteroid for a follow-up subsurface nuclear detonation within that crater, which would generate a high efficiency of conversion of the nuclear energy into propulsion energy to the asteroid, which would theoretically either break the asteroid into smaller chunks or cause it to change course completely. As of now, NASA is expected to be launching its Asteroid Impact and Deflection Assessment mission by using the DART system to demonstrate the kinetic impact technique to deflect an asteroid with a mission already set that will encounter the asteroid system Didymos in 2022. NASA's fourth objective is to increase international cooperation to better prepare the rest of the world for the possibility of an asteroid strike. With this being a global hazard that we must all face together, the best manner of approach is to address the issue with absolute cooperation. NASA's Planetary Defense Coordination Office is working with the United Nations Committee on the Peaceful Uses of Outer Space to plan the possible scenarios of international response that need to be addressed. This UN committee is the one that created the International Asteroid Warning Network, a group of asteroid tracking astronomers and observations around the world who share useful data about near-Earth objects. The fifth and last objective outlined by NASA is to have the US government come up with a solid implementing plan that would go into effect if a large asteroid did manage to crash into Earth, with little to no warning. Emergency procedures regarding asteroid impacts have already been presented by NASA and FEMA since 2010, with this new report calling for government agencies to strengthen and assure its response towards emergency procedures and action protocols. While currently, no space agency has ever done a deflector mission yet to test the viability of these conceptual means of deflecting massive asteroids, the increase of more powerful technologies provide better understanding and analysis of how these actions may provide the salvation we might all need someday. And while the increase in awareness of asteroid threats have become more evident, initiating a more proactive approach is necessary, not only to know the effectivity of these solutions, but to better prepare all involved agencies here on Earth, and basically each one of us on the planet as well, for the likelihood of its occurrence. So what do you think about NASA's plan to save Earth from asteroids? Sound off in the comment section below. And if you enjoyed the video, thumbs up, subscribe, and ring the notification bell. That way you never miss out on future uploads. Until next time.